Marcelo. Sa gitna ng mapanubok na panahon, magkahatid sa kakibat ay diskusyon. Sama-sama tayo, kahit magkalayo. Sa programang ito, tiyak ang pagkatuto. Teleradyo, Teleradyo Marcelo. Teleradyo, Teleradyo Marcelo. Teleradyo, Teleradyo Marcelo.
Hello, Delpilarians. A blessed afternoon to everyone. We're on our third week, fourth quarter discussion in statistics and probability here at Teleradyo Marcelo, ang telearalan ng bawat manlaleno. I am Ms. Freya Rose as our modest, your teacher podcaster for this session. In our previous topics, we've encountered a lot of competitions, right? So let's chill a little bit this afternoon as we talk about these basic concepts of hypothesis testing. For this week, our content standard will be: the learner demonstrates understanding of key concepts of test of hypothesis on the population mean and population proportion. And for our performance standard, the learner is able to perform appropriate tests of hypothesis involving the population mean and population proportion to make inferences in real-life problems in different disciplines. And for our most essential learning competencies, at the end of this teleradio session, you are expected to: number 1, illustrate null hypothesis, alternative hypothesis, level of significance, rejection region, and types of errors in hypothesis testing. For number 2, identify the parameter to be tested given a real-life problem. 3, formulate the appropriate null and alternative hypothesis on a population mean. Lastly, identify the appropriate form of test statistic when the population variance is assumed to be known, the population variance is assumed to be unknown, and the central limit theorem is to be used. Before I discuss the lesson for today, let's have a short activity. Watch and listen carefully, and do not forget to type in your answer on our comment section below. Make sure that you have a pen and paper with you so that you can take down notes all important terms that I will discuss today. Right, so are you ready? This activity is a multiple choice. All you have to do is to choose the letter of the correct answer in each number. Let's start. For number 1, it refers to the whole group under study or investigation. Is it A, population, B, sample, C, random sampling, or D, subset? So what do you think? You may start answering now. Okay, let's see if you got it right. Time's up. If your answer is A, population, then you are correct. Okay, next, given. It is a subset taken from a population, either by random or non-random sampling technique. Is it A, population, B, sample, C, random sampling, or D, subset? What do you think? So let's see if you got it right. Okay, time's up. If your answer is B, sample, then you got it right. Okay, next, number 3. It is the average value of all data from a population or sample. Is it A, variance, B, population, C, standard deviation, or D, mean? Okay, you may start answering now. So what do you think is the answer? Okay, time's up. If your answer is D, mean, then you are correct. All right, so let's have the fourth question now. What will be the degrees of freedom of the data with a sample size of 20? Is it A, 17, B, 18, C, 19, or D, 20? So what do you think? I'll give you time to compute and to type in your answer, and you may start now. So let's see if you got it right. All right, time's up. If your answer is C19, then you are correct. Let's recall, for us to get the degrees of freedom, that is n minus 1, wherein our n here is the sample size. So we have here 20 minus 1 equivalent to 19. And that's the value of our degrees of freedom. Right, for the fifth question, these symbols mu and sigma represent the mean and standard deviation for which of the following choices? Is it A, population, B, sample, C, sampling distribution, or D, none of these? All right, so you may start answering now. All right, time's up. If your answer is A, population, then you are correct. Okay, now let's have the last given. Number 6. What is the length of the confidence interval with a p-value less than 0.355 and greater than 0.470? Is it A, 1.115, B, 0.115, C, 0.1115, or D, 1.1155? Right, so I'll give you time to compute and to type in your answer. Okay, time's up. If your answer is B, then you are correct. For us to get the length of the confidence interval, we have to compute or subtract the upper confidence limit minus the lower confidence limit. Here we have 0.470 minus 0.355 thousandths give us 0.115 as the value of length of confidence interval. All right, so that's all for our activity today. Good job, Delcolarians. Thank you for your participation. I've mentioned a while ago that we're going to talk about these basic concepts of hypothesis testing. We make decisions every day, right? Some of them are important, while others are not. In decision making, we usually follow certain process followed by an appropriate interpretation. Here in statistics, decision-making starts with a concern about a population regarding its characteristics denoted by its parameter value. And to give you an overview or a glimpse about our lesson for today, I'll give you an illustration. So let's say your friend told you that the country will experience thunderstorms in the next few months. Will you believe your friend? This pronouncement given here is an assumption that is maybe true or false. And such assumption could be referred to the process or procedure in statistics called hypothesis testing. So let me define first this hypothesis. Hypothesis is a proposed explanation, assertion, or assumption about a population parameter or about the distribution of a random variable. With a hypothesis that we have, we need to decide whether it's true or false and take an action if we're gonna accept it or not. And to do that, we have to go through this hypothesis testing. So when we say hypothesis testing, it is a statistical method applied in making decisions using experimental data. Basically, it is testing an assumption that we make about a population. And we have two types of hypotheses. Those are the null hypothesis and alternative hypothesis. Let's have this first, the null hypothesis. It is denoted by H sub 0 or H sub O in other books. It states that there is no difference between a parameter and specific value, or that there is no difference between two parameters. We use the symbols here like equal to, greater than or equal to, and then less than or equal to. Note that we always have an equal sign in formulating our null hypothesis, and it can be written as follows. Mu is equal to mu sub 0, mu is less than or equal to mu sub 0, or mu is greater than or equal to mu sub 0, wherein our mu symbol here represents population parameter. And for this mu sub 0, it represents our specific value. All right? While this alternative hypothesis, denoted by H sub 1 or H sub A, states that there is a difference between a parameter and specific value, or that there is a difference between two parameters. And the symbols that we're going to use in formulating alternative hypothesis are the following: not equal to or unequal sign, greater than or less than. And in symbol, it can be written as mu is not equal to mu sub 0, mu is greater than mu sub 0 or mu is less than mu sub 0. So this alternative hypothesis is the opposite, all right? It contradicts our null hypothesis. So basically, the process of hypothesis testing involves decision-making between two opposing hypotheses. And these two hypotheses, which are the null and alternative hypotheses, are formulated in such a way that the one is the negation of the other. Meaning to say, if one is true, then the other must be false. All right? So in the next slides, we have here common phrases used in hypothesis testing that will guide you in choosing the appropriate or correct symbol to be used. So if you encounter these phrases is equal to, is the same as, is exactly the same as, or has not changed from, then we're going to use this symbol, an equal sign symbol. For this unequal sign symbol or not equal symbol, we have here is not equal to, is not the same, is different from, has changed from. And for this less than or equal to, we have here is at most, is not more than, is less than or equal to. And for this greater than symbol, we have is increase, is greater than, is higher than, is above, is bigger than, is longer than. And for this greater than or equal to symbol, we have here is at least, is not less than, or is greater than or equal to. And lastly, for our less than symbol, we have here is decrease, is less than, is lower than, is below, is smaller than, is decreased or reduced from, or is not more than. So if you encounter these phrases, you can easily choose the appropriate symbol to use. To better grasp or to better understand the idea, let's have an example. Let me read the problem. The owner of the factory sells a particular bottled fruit juice, claims that the average capacity of their product is 250 ml. Is the claim true? Right? So the first thing to do here is to identify our parameter. Since in our given problem here, use the word average and the word is, that indicates that we have an equal sign or corresponds to equal sign symbol, we can say that our parameter of interest is that the mean or mu is equal to 250. With this parameter, we can now formulate our null and alternative hypothesis. Let's have first the null hypothesis. Since null hypothesis states that there is no difference at all or there's no changes, we can say that the null hypothesis here is that the bottled drinks contain 250 ml per bottle, and this is our claim, all right? And for our alternative hypothesis, we're just going to contradict our null hypothesis. If this null contain 250 ml, for our alternative hypothesis, we have here the bottled drinks do not contain 250 ml per bottle. And if we're going to write it in symbol, we have here mu is equal to 250 for our null, and for our alternative, mu is not equal to 250. And to deepen your understanding about this hypothesis, let's have another example. A farmer believes that using organic fertilizers on his plants will yield greater income. His average income from the past was 200,000 pesos per year. State the hypothesis in symbol. If you notice here in our problem, it uses the word or it used the phrase greater income, right? So we can say that our parameter of interest is that the mean or the mu is greater than 200,000 pesos. And for our null hypothesis, since it's always have an equal sign, we can state that mu is 200,000 pesos for our null hypothesis. And for our alternative hypothesis, this greater income phrase here is associated with greater than direction. So we can say that our alternative hypothesis is mu is greater than 200,000 pesos. If you can still recall, in formulating the alternative hypothesis, we use symbols like unequal, less than, or greater than. That's why here, our alternative hypothesis is our claim, since it uses here in parameter greater than 200,000 pesos. Okay? An easy one, right? Now let's have the third example, but this time you will be the one to answer. Okay, let me read it first. The average waiting time of all customers in a restaurant before being served is less than 20 minutes. State the hypothesis in symbols. Alright, so I'll give you time to think and to formulate your hypothesis, and your timer starts now. So let's see later if you got it right. Okay? Okay, time's up. So here in our given problem, we use the phrase less than. It indicates that our parameter of interest is that mu is less than 20. Alright? So if your null hypothesis is mu equals to 20, then you are correct. And for our alternative hypothesis, if your answer is mu is less than 20, then you are also correct. And note that our alternative hypothesis is our claim. Okay? Okay, great job, Deltularians. And to continue our discussion, now let's have the types of tests. We have two types of tests, the directional and non-directional test. Note that we can determine whether a test is a directional or non-directional test by just looking at how our alternative hypothesis is being expressed. So it depends on our given alternative hypothesis. So let's have this first. The directional tests are also known as one-tailed test. It is when the rejection region is lying on either left or right tail of the normal tail. So we have two types of directional test, the right directional test and the left directional test. Let's have this right directional test. It is when the region of projection is on the right tail. It is used when the alternative hypothesis uses comparatives such as greater than, higher than, better than, superior to, exceeds, or other phrases. And for the illustration, if we're going to illustrate it into our normal curve, it is located here on the right tail of our normal curve. Right? So this is our rejection area. Okay? Next, the left directional test. It is when the region of projection is on the left tail. It is used when the alternative hypothesis uses comparatives such as less than, smaller than, inferior to, lower than, below, etc. So if we're going to illustrate it in our normal distribution curve, it is lying here on the left tail of our normal curve, the rejection area. All right? So let's have an example for this right and left directional test. For the one tail to the right, or the right tail test, our null hypothesis here is the average life of batteries is less than or equal to 15 hours, or in symbol, mu is less than or equal to 15. Since our alternative hypothesis contradicts our null hypothesis, we can say that the average life of batteries is greater than 15 hours for our alternative hypothesis. And in symbol, we have here mu is greater than 15. So this greater than phrase and this symbol here, the greater than symbol, indicates that we have a right tail test. Okay? Or a one tail test to the right. Now let's proceed to the one tail to the left. For the null hypothesis, the average life of batteries is greater than or equal to 15 hours, or in symbol, mu is greater than or equal to 15. And for our alternative hypothesis, let's just contradict our null. The average life of batteries is less than 15 hours, or in symbol, mu is less than 15. Okay, so this phrase less than, or since we use the phrase less than here and this symbol, we can consider it as one-tailed test or left directional test. Okay? So that's all for this directional test. Another type of test is this non-directional test, or also known as two-tail test. It is when the rejection region is lying on the both tails of the normal curve. It is used when the alternative hypothesis uses words such, not equal to, significantly different, and etc. So for our illustration, here in our normal distribution curve, the rejection area or region of rejection is lying on the both tails of the normal curve. Okay? For example, the null hypothesis is the average life of batteries is equal to 15 hours, or mu is equal to 15. And to contradict this, our alternative hypothesis is the average life of batteries is not equal to 15 hours, or mu is not equal to 15. And this symbol or phrase here is not equal to indicates that we have here a two-tailed test or non-directional test. All right, so going back to our examples earlier, let's identify the type of test fits in the given alternative hypothesis, and you will be the one to identify it. Okay, don't worry, I'll give you time to think and to type in your answer. All right, so for this example one, our null hypothesis is that mu equals to 250, and our alternative hypothesis is mu is not equal to 250. So what do you think? Is it a one-tailed test or a two-tailed test? So you can type in your answer now. All right, so if your answer here is a two-tailed test, then you are correct. Because this phrase do not contain, and the symbol unequal sign, it indicates that we have here a two-tailed test, or also known as non-directional test. All right. Next, for the null hypothesis equals to mu equals to 200,000, and then alternative hypothesis is mu is greater than 200,000. What type of test fits here? You can type in your answer now. Okay, let's see if you really understood the lesson. All right, time's up. If your answer here is one-tailed test, then you are correct. To be specific, it's a right-tailed test or right directional test. Right? So this symbol here indicates that we have a right-tailed test. Okay, thank you for your participation, Delpilarians. I hope that everything's clear. And to continue our discussion, let's have the types of error. We have two types of error, the type 1 error and the type 2 error. But let's have this first. If the null hypothesis is true and rejected, then it is a type 1 error. The probability of committing a type 1 error is denoted by alpha. And for the type 2 error, if null hypothesis is false and then you accept it, then it is a type 2 error. The probability of committing type 2 error is denoted by beta. Right? So let's have an example. So let's say Maria insists that she is 30 years old when in fact she is 32 years old. What error is Maria committing? So since Maria is rejecting the truth, she is committing the type 1 error. So that is the concept of our type 1 error, if you are rejecting the truth. All right, next example. A man plans to go hunting the Philippine monkey-eating eagle, believing that it is a proof of his method. What type of error is this? We all know that hunting Philippine eagle is prohibited by law. Thus, it is not a good sport. So it is a type 2 error. So that's the concept of this type 2 error. If you are accepting the false statement, then you are committing a type 2 error, right? So to summarize the difference between the type 1 and type 2 error, take a look at the table below. This is the common table that our statisticians use to summarize our type of errors, right? So if our null hypothesis is true and then you accept it, then that's a correct decision. But when our null hypothesis is true and then you reject it, then you are committing a type 1 error. If our null hypothesis is false and then you accept it, then you are committing a type 2 error. And for our null hypothesis that is false and then you reject it, then that's a correct decision. Okay, so I hope that it's clear to you. Now let's have the continuation of our discussion. In the next slide, we have here level of significance. Okay, so this significance here is defined as the quality of being statistically significant. All right, so this level of significance here, denoted by alpha or the symbol, refers to the degree of significance in which we accept or reject the null hypothesis. Additional information: in public health research, the alpha is usually 0.01 or 1%. In social science, alpha is usually 0.05 or 5%, and 0.10 or 10% in other studies. In symbol, it is written as alpha is equal to 0.01, alpha is equal to 0.05, alpha equivalent to 0.10. Furthermore, if the alternative hypothesis use this unequal symbol here, then the alpha will be divided by 2. So for the alpha equivalent to 0.01, if we're going to divide it by 2, that's equivalent to 0.005. And for an alpha equivalent to 0.05, alpha over 2 is equivalent to 0.025. And lastly, for an alpha equivalent to 0.10, our alpha over 2 is 0.05. So this has been discussed in our previous topic. All right. So using this level of significance, we can determine our critical region or the critical region of our problem. So when we say critical region, the critical region, or also known as the rejection region, is the set of all values of the test statistic that causes us to reject the null hypothesis. On the other hand, the non-rejection or the acceptance region is the set of all values of the test statistic that causes us to fail to reject the null hypothesis. To add, the critical value is a point or our boundary on the test distribution that is compared to the test statistic to determine if the null hypothesis would be rejected. And to illustrate this tree, let's use this normal curve. Right, so here we are using the two-tailed test, wherein our rejection region or critical region is lying on the both tails. Right? And for our non-rejection region, the unshaded part of our distribution curve or normal curve. And for this boundary here, this one, all right. So that is what we call the critical value. Okay. Okay, so in the next slide, we have here the commonly used significance and its corresponding critical values of Z distribution. For the level of significance equivalent to 0.01, and if we have a one tail, that is equivalent to positive 2.33 or negative 2.33. For a two-tailed, we have positive negative 2.575 thousandths. And for the level of significance equivalent to 0.025, for one tail, we have 1.96 or negative 1.96. For the two-tailed, we have positive negative 2.24. For the level of significance equivalent to 0.05, with one tail, we have positive 1.645 or negative 1.645. And for the two-tailed, we have positive negative 1.96. And lastly, with an alpha equivalent to 0.1 or 0.100, we have a one-tailed equivalent to positive 1.28 or negative 1.28. And for the two-tailed, we have positive negative 645. All right, so now let's have an example for you to better understand this. Okay, let's read it first. So we're going to write the critical value of the given. And the given is two-tailed test with an alpha equivalent to 0.01, wherein our n is 67. So if you notice here, our n, okay, we just change the pen. Our n is greater than 30. It indicates that we're going to use the Z distribution table, right? Z distribution table with an alpha equivalent to 0.01, and this is a two-tailed. Right, so going back to our table earlier, let's see if what is the critical value of this. With an alpha equivalent to 0.01, so here's the 0.01, this one, and then we have a two-tailed test. Okay, so we can say that the value is positive negative 2.575. Okay, so that's all for this example number 1. Now let's have our example number 2. Okay, it is a right-tailed test, so meaning to say we have a one-tailed here. Okay, with an alpha equivalent to 0.05 and sample size equivalent to 25. And as you can see here, we have here n that is less than 30. It indicates that we're going to use the table or the distribution table. So for us to find the critical value using this distribution, we need to find first the degrees of freedom. So we have n minus 1. Wherein our n here is 25 minus 1 equivalent to 24. So take note of that. Our degrees of freedom is 24 with an alpha equivalent to 0.05, and we have a one tail here. So let's have our table of the distribution. All right. So our degrees of freedom is here. 24 with an alpha equivalent to 0.05, and it's one tail. It's one. All right, so the value is 1.711. Let me just write here. Critical value is 1.711. Okay, and that's all for this example number 2. In the next slide, for example number 3, you will be the one to answer. So get ready. For the given here, we have a two-tailed test with an alpha equivalent to 0.05 and with a sample size equivalent to 35. So what do you think would be the critical value here? So notice that we have here n, which is greater than 30. So what is the appropriate distribution table to be used? What do you think? All right, so we're going to use the Z table or Z distribution table. So going back to our table earlier, take a look at this table and then comment down below your answer. What is the critical value of our given? Right, so going back to our given here. So I'll give you time to type in your answer. Let's see if you got it. Okay, time's up. If your answer is critical value equivalent to positive or negative 1.96, then you are correct. Since we have here a two-tailed test with an alpha of 0.05, so going back to our table, 0.05 is here with a two-tailed 1.96, positive, negative 1.96. Right? Another example here is, we will illustrate the rejection region given the critical value and identify if the t-values lie in the non-rejection region or rejection region. All right, so for the first given, with a critical t-value of negative 2.33 and computed t-value of negative 1.38. So let's use this normal distribution curve. Okay. So negative 2.33 here. Right, so this is our rejection region. Right? And for our computed t-value, our negative 1.38 is somewhere located here. Negative 1.38. And our t-value here is at the non-rejection region because it lies outside the rejection region. Okay? Next,
For letter B, critical t-value of 2.12 and computed t-value of 2.15. So you will be the one to answer this. If our computed t-value is at none or rejection region. And I'll give you time to think and to type in your answer. And you may start now. So let's see if you got it right. Okay, so time's up. So let's see. Our positive 2.12 or critical value is somewhere located here. So this is our rejection region. Okay. And for our computed p-value, that is located here, okay, 2.15. All right. So if your answer is the computed p-value is at rejection region, then you are correct. All right. So thank you for your participation. Let's have the last part of our discussion, which is identifying appropriate test statistic involving population mean. Okay, so let me define first this test statistic. Okay. It is a value used to determine the probability needed in decision making. It is a random variable that is calculated from sample data and used in a hypothesis. So after formulating our hypothesis, we need to identify the proper test statistic to be used on our problem. The first thing that we need to consider is whether the sample size is greater than or equal to 30 or less than 30. If it is greater than 30, then we're going to use the z-test. If sample size is less than 30, then we need to identify if our population standard deviation or variance is known. If it is known, then we will use the z-test. If it is unknown, we will use the t-test instead. Again, when we say the z-test, the sample size here is assumed to be normally distributed. And the z-score is calculated with population parameters such as population mean and population standard deviation, right? And the normal or sample size here is large. And for the t-test, the sample is also assumed to be normally distributed. A t-test is used when the population variance or standard deviation are not known. So take note of that. The sample size is less than 30. And the central limit theorem states that if the population is normally distributed or the sample size is large and the true population mean mu is equal to mu sub 0, then z has a standard normal distribution. When the population standard is not known, we may still use the z-score by replacing the population standard deviation by its estimate sample standard deviation. All right, so for you to be guided, let's have this chart. When the value of sample size n is greater than or equal to 30 and then less than 30. So let's have this first. If it is greater than or equal to 30 and your population standard deviation is known, then we're going to use this z-test. And if our sample size is less than 30 and then our population standard deviation is known, we still use this z-test. And for the sample size that is less than 30, but our population standard deviation is unknown, we're going to use the t-test instead. So let me give you an example. So here we will identify the appropriate test statistic to be used given in the problem. So let me read it first. The average score for an entire school is 75 with a standard deviation of 10. What is the probability that a random sample of 5 students scored above 80? Okay, so we need to identify first the given or the parts of the given. So here we have average for an entire school. So we have population mean equivalent to 75 and the population standard deviation equivalent to 10. Right. And what else? We also have here a random sample of 5. So n is equal to 5. If you notice here, our n or sample size is less than 30. And our population standard deviation is known. So going back to our chart earlier, if our n is less than 30 and then our population standard deviation is known, then we're going to use the z-test. Right? So going back here,
The appropriate test statistic to be used here is the z-test. Okay, easy, right? So next example. From a random sample of 100 students who have passed a statistic course, the average score was 71.8, assuming that the population standard deviation is 8.9, with a significance level of 0.05. Does it seem to signify that the average score is more than 70? Right, so let's identify the parts of the given. We have your random sample of 100. So n is equal to 100. And an average score equivalent to 71.8. Okay. We also have here a population standard deviation equivalent to 8.9. Okay. So if you notice, our n here is greater than 30. And population standard deviation is known. So going back to our chart earlier, what do you think is the appropriate test statistic to be used? Is it the z-test or the t-test? Let's see if you really understood this lesson. Okay, if your answer is z-test, then you are correct. Because we have here n greater than 30, which is here. And then population standard deviation is known. So we're going to use the z-test, right? So great job, Lawrence. Now let's have the third or the last example. Okay. An English teacher wanted to test whether the mean reading speed of students is 550 words per minute. A sample of 12 students revealed a sample mean of 540 words per minute, with a standard deviation of 5 words per minute. At 0.05 significance level, is the reading speed different from 550 words per minute? So let's identify the parts of the given. So we have here population mean equivalent to 550. And then sample size equivalent to 12, this one. With a sample mean equivalent to 540 words. And lastly, we have here, all right, with a standard deviation equivalent to 5, which is the sample standard deviation. So what do you think is the appropriate test statistic to be used here? So going back to our chart here. So what do you think is the appropriate test statistic to be used? And you may type in your answer now. Is it the z-test or the t-test? Okay, time's up. So let's see. Let's analyze it. Here in our given, our sample size is less than 30. And notice that our population standard deviation is unknown. So here, if your answer is t-test, then you got it right. Okay, so thank you for your participation, Dr. Lawrence. That's the end of our discussion for today. To develop more of your understanding about our discussion today, I'll leave you with homework. So ready your cell phones or laptops to capture a screenshot of the next slides. And this will be also uploaded in your respective Google Classroom. Okay, so let's start. Okay, for the test 1, state the null and alternative hypothesis of the following statements. This is 4 points each with a 4 item. All right, so I guess that you already captured a screenshot of this slide. Now let's have the second slide. The test 2 determine if one-tailed test or two-tailed test fits the given alternative hypothesis. And for the test 3, illustrate the rejection region given the critical value and identify if T values lie in the non-rejection region or rejection region. We also have here 2 items. Okay, so that's for the second slide. I guess that you're done capturing this slide. So let's proceed to the last slide, which is this fourth. Identify the appropriate test statistic to be used in each problem. It is 2 points each and then with 3 items. Okay. All right, so I guess that you already captured a screenshot of this slide. A very fruitful afternoon discussion with Drew our dear Delpularians. Before we end, let me send to you my sincere appreciation for your time and participation. I would also like to thank all the people behind this Teleradio session. Thank you for your hard work and determination to make this program possible. Now I would like to encourage everyone to like and follow our Facebook page and subscribe on our YouTube channel. Before we end, let me leave you with this reminder or quotation by Enrico Fermi. There are two possible outcomes. If the result confirms the hypothesis, then you've made a measurement. If the result is the contrary to the hypothesis, then you've made a discovery. Stay tuned for more math discussions here in Teleradio Marcelo, ang telearalan ng bawat mananalig. See you again next week. Bye!
Magandang araw, Delphilarians! Sa taong po ito, pag-iiwan natin ang isang globe. Mabuhay ang Pilipinas!
Makinig, manood na sa teleradyo. Makinig, manood na sa teleradyo. Teleradyo, Teleradyo Marcelo. Sa gitna ng mapanubok na panahon, magkahatid sa kakibat ay diskusyon. Sama-sama tayo, kahit magkalayo. Sa programang ito, tiyak ang pagkatuto.